thank you, everyone. What an honor to be here. I'm Ari Kaplan, and I've had the honor of working in professional sports for many decades. So I'm going to spend a little time giving you the viewpoint of what it's like working for a team, what I've seen of the changes of data and AI over the decades, and a little taste of what's I feel is the modern data platform and what's to come. And this is such an incredible event. I know there have been a lot of speakers talking of all of the different aspects of what's to come, but from the actual data and AI perspective, there's incredible opportunity. So I was asked to give one slide on what it's been like of my personal journey. Probably most known for Moneyball, but also having created and run the Chicago Cubs analytics department. So going around the corner, not only collecting and using the data from all the incredible vendors that you see and beyond, but looking at players from the humanistic perspective, having been a major league scout, talent scout, looking at people from a young age through signing onto professionalism. So if anyone's familiar with the Chicago Cubs story, they had not won a World Series for 108 years. It was the largest drought in the history of all sports worldwide. So I was brought in, I had been consulting for the team for about 10 years. A new owner came in, very data-driven, wanted to kind of transform the way that they thought from kind of the gut feel to using data and analytics to help determine who should we draft, who should we develop, what strategy should we use. So the gentleman there, Anthony Rizzo, he was the player when the ball hit his glove at first base. That very millisecond was when the Cubs drought ended, 108 years before the Titanic and everything like that. But I had the honor of being the scout to look at him from a humanistic perspective as well as from the analytics. And both said he would be an elite player. And in fact, I said to the owner and to the general manager, he would be an everyday all-star type of player. And at the time, he was in the minor leagues. He was still young. He actually had cancer as a child, so he missed a year of playing. So not every scout thought that he would do well. But that was one of my greatest moments to help the fan base achieve that after such a long drought. So I don't know if anyone has heard of this musician, Taylor Swift. She touring the world now. Anyway, that's her boyfriend, Travis Kelce. I did a fun interview with him on how he uses data and AI. And microscopic details, won the Super Bowl. But what was most fun for me is I have a daughter. She's 20 years old in college. She said, "Dad, do you know how important Travis Kelce is to my generation?" I'm like, "Do you know how important he is to data and AI?" So that was fun. And then I was also asked to talk just a little bit on the bottom, being in Germany. I always encourage people at some point in their life to do something positive in whatever capacity you have. And so for me, it's working with human rights groups to find missing in action prisoners of war. And one of them was Raoul Wallenberg, who was a Swedish diplomat during World War II that rescued tens of thousands of Hungarian Jewish people. And aside from Databricks, I'm also the president of the investigation into his fate. So myself and the gentleman in the bottom, Marvin Makinen, was actually arrested as a spy in Berlin in Germany and got out on this spy exchange. So trying to find out what happened to this humanitarian that was captured and disappeared in the Soviet gulag is a big part of my life. So the next thing is, I always say that every 4 or 5 years, there's a major change in data and analytics. A long time ago, I worked at Oracle. I was the president of the Worldwide Oracle User Group, and that was like the best technology out there. If you wanted robust data, you would house it in an Oracle database, something that would never crash, always highly available, always performative. But the reason I bring that up is fast forward 20 years, and that's no longer the case. 1 billion records, you would think that would be all you need, but now we're talking about large language models. We're talking I saw Second Spectrum Genius up here talking about mesh data. We're talking now billions, but actually hundreds of billions, and now trillions of data. So to be able to scale all of that data has been a real challenge. So there's new modern data platforms that can scale in size and cost out there. Also mobile business, created one of the first mobile business software companies out there, Expand Beyond. And like today, sometimes with Gen AI or even with that augmented reality, you get a lot of pushback. And I would get pushback saying, Ari, I will never, ever check my email when I'm not at home. This will never happen. No one will do it. And now it's commonplace. So if there is a value in something, in this technology you're seeing, it will happen even if you get pushback, if there's value. So you had mentioned Moneyball. The movie, it's kind of the story of my life. It specifically was about the Oakland Athletics, but the directors had called me up and asked me if they could do a character sketch, not of the Brad Pitt, but the kind of guy in the background who was more of the analyst. So did some consulting with the film, what was a day in the life of an analyst like? And that slogan is adapt or die, which for me is a little bit too much. Like if you don't adapt, the football players who are resting, like you are not going to win, but I'm not that dramatic. So I would say maybe adapt or don't do as well as your opponent. Although with Gen AI, things are accelerating pretty quickly. So Moneyball changed the whole industry. It went from people being kind of aggressive and negative towards what we had to say to being neutral to actually changing the world. So now this event, you see there's so much acceptance of data and AI, there's like an overload of information. But it did change the way the game is being played. So if you look at the chart, the one on the bottom is one of my favorites. It is how you defensively reposition. So if you say, stand here, and you have an 81% chance of the ball coming to you, stand here and you have a 10% chance, you're gonna stand over here, right? And when we started that with the Cubs in the bottom left, 2010, only 3% of all balls in play, they would move back and forth. 3%. As a Cubs person, we actually liked that. We wanted to have the advantage. We wanted nobody else to do it. So we would actually save about 80 to 90 runs per game, which was equivalent to about 8 or 9 wins per game per season. Huge amount just by using data. That was the difference of making the playoffs or not. But it didn't get adapted quite immediately. You could see the trend goes up, and it took a good 6 years, even though we would have success, for other teams to adapt it. Even managers would say, I want you to shift, and the players wouldn't. And then it happened so much that just a few years ago, more than half of all balls in play were shifted upon. 3% to over half, so much so that fans thought the game was boring, and baseball actually eliminated or reduced the ability to shift just a couple of years ago, changed the game completely. Those circular dots, that's the NBA. The game of the NBA changed dramatically, going from 2-point shots to now teams are taking 3-point shots most of the time. Totally changed. So one of the challenges is not just collecting data and taking action on it, but the concept of data drift. When your data changes, in baseball we have a ton of rule changes, the strategy changes. Humans are dynamic. Humans have behavioral psychology. So if you change, like you'll see in football, the question now is go for it on 4th down and short. And if you change your strategy, the opponents are going to adapt. So it's like an interactive chess game, so to speak. So that's where a lot of the challenge is how can you detect data as it's changing rapidly? So in addition to baseball, I created and led the Cubs analytics, the Dodgers, the Baltimore Orioles, who had a lot of recent success, but also spent the last couple years prior to joining Databricks running around the world with McLaren and Formula One with their race strategy team, as well as with their engineering team. And if you have heard of Drive to Survive, shows the importance of media and consumers and the power of the fans. This show came out on Netflix about 5 years ago, and the viewership, it became the #1 program on Netflix overall, and the #1 most watched show also just for females on Netflix, since it was the drama behind the personalities of it. 73 million new fans, incredible success. And so being part of that was pretty fantastic. So that's me in the middle with Lando Norris and Daniel Ricciardo. So I encourage people, we are collecting numbers, but it's a numbers game, but these are also humans. So you could give them advice, and sometimes it works, sometimes it doesn't. Sometimes players take the advice in numbers, sometimes it's in words, sometimes it's in graphics like heat maps, and sometimes it's just a shoulder to cry on. So that's me showing, like Lando Norris, I created a fantasy Formula One game, got him to play it, and he tweeted it out and Instagrammed it out, went to like tens of millions of people. But that's me doing what's called the hot lap, being in the car. So I encourage everyone here who is working with data to look at the information from the perspective of a player. Are they going to take action on what they're providing? Is it just trivia, or is it something that's actionable? So that's me in a hot lap, and I'm by no means as an expert as a true bona fide Formula One driver, but I noticed the car was shaking, and that made me a little bit dizzy. So it may change my depth perception. So I just came up with the idea, maybe the shaking car affected some of the drivers when they would do turns. And that indeed turned out to be a worthy feature. And we're able to work with some of the drivers, work with the car to make it less bumpy, which was a challenge, but wouldn't have thought of that if I hadn't actually gotten into it. And this slide is just a fun thing. It's not just the business of sports. In Formula One, in all of the sports, it's a huge media entity. So just one race, getting to meet and interact with all types of celebrities, Paris Hilton, Michael Douglas, not just photo ops, but like literally talking with them for quite a while. And in terms of use cases, at this conference, we went through a lot. A lot of them were in the fanalytics space, so fan experiences. I'm personally excited of, like the drones, the augmented reality. Not everyone's into it. I personally am. That will, and I'm not the young demographic, that will take over all fan experiences. But on the field and off the field, how do you project player performance a year from now, 5 years from now? What's the economics of the contract? Is a player worth $5 million or $20 million? And how do you figure forward-looking of how a player might do? They're only 15 years old. Like, what does a Lionel Messi, when he was 15 years old, look like? Not necessarily what he looks like today, and what characteristics can you quantify that could project forward? So when Messi was a kid, one of his characteristics was as he would run through the field, the ball would go no farther than 3 feet from him almost all of the time. So now you can use a multitude of the vendors that are here to go and look at broadcasts of 1 million youth soccer players and quantify automatically Messi characteristics of the acceleration, deceleration, the footwork, and what 15-year-olds today exhibit what Messi did when he was 15 years old. So you could do that at scale right now, which is incredible. I know we've seen a lot of videos and solutions that show limb collection and now mesh collection of the entire surface of the body. But what's important for me is the most fun and the most important part now is to make what are called features or new variables out of this data. So it's not just the dots moving around, but then you start making new what are called features. This player in the background is on the ground. Another player is leaning backwards. Another player is running forward. This player is aggressive. Then you can combine features to make entire new features. This player is open. This is a formation. This is a rapidly changing formation. So whether you're a vendor, if you can create these features and sell them to the teams, or like myself, when I was on a team, I would try to make as many features as possible, and then you can run it through data science algorithms to see which features and which combinations lead towards like a shot on goal. It's been incredible, and you have to understand the dynamics of player behavior. The other thing that is super important is it's not just collecting the numbers and doing data quality on it, it's also understanding the game itself. So, there's some, when we see American football, there's some data that could be incredibly helpful for reducing injuries. But some data, you need to really understand the dynamics of the game, how a player is anticipating a move, where their eyes are looking. If you haven't played or watched football enough, you may miss that innuendo. Like when I was with the team, one of my interns made a recommendation for us to trade a player, but the player was injured. And if the GM had signed that player, it wouldn't have ended up well. And the intern said, I didn't know injury was a data input, and just didn't know the game, and that would have been a problem. So another thing, this image is really a collection of multiple images strung together, so your eyes as a human can fall upon what's consistent and what's not. So that's just another good way of analyzing. So what's next is, in terms of data itself, when I talked about Oracle, that was structured database, something called the data warehouse, backwards looking. Then, not too long ago, a new paradigm called the data lake came out. That's unstructured data. A lot of what we see, the JSON of moving dots, of videos, of broadcast, of audio, of unstructured data, and that's forward-looking. So there's this big divide between the two that is incompatible. And to make the best generative AI or the best traditional AI, the more data you have, the better your insights will be. So Databricks, where I work, created this whole marketplace called the Lake House. It's a play on the words data lake and data warehouse. And right now, that's commonplace. There are a couple companies that do this. Went from 0% of companies implementing it to now 75% of major Fortune 500 companies have a lakehouse, but it's all unified, everything in one environment, structured, unstructured. And that's super important since, like in sports, you're going to want to incorporate both video as well as the traditional metrics. How hard did they kick the ball? What's their fastest acceleration, deceleration rates? The more data you can combine of different data types, what text did scouts write? What text did the medical staff write? That brings to more important types of insights. So, a couple success stories. Texas Rangers, if you've been following American baseball, won the World Championship, and we've been with them throughout the entire season from spring training onward. And they were able to incorporate kind of like their data feeds. All of their 20 different vendors all merged into one, making it super fast time to market. La Liga here, being able to ingest all of these data frames, process it, and make predictive analytics for their fans and for their team is incredibly fast. The Philadelphia Union, American soccer, making these data pipelines much faster. And I also want to call out Michelle Smith, who's here with me with Databricks. You could talk to myself or her afterwards, but have been invaluable helping make these customers and many more success. So this unified platform is super important since you're going to get data as a team or as a broadcaster from all different sources. And if it's siloed, then you're not going to make observations on it. 93% of typical companies don't know what data they have. It's not labeled, it's not tagged, it's not searchable. So having this new paradigm, what I labeled as a new dawn, is the next paradigm. So the data lakehouse, again, more than 3/4 of all companies have this. So the next thing, has been abundantly clear here, is generative AI. So generative AI, to me, is not just large language models, which the media has attention, or text-to-speech, or these incredible use cases of making broadcasts in 70 languages, but it's also inward-looking. Your data employees will be able to be more efficient. Writing code, you can use plain English or plain German or whatever your language is to write SQL code. I want to understand which football player has the best forward aggressiveness, or which striker tends to show their left foot or right foot when they're trying to score on a goal. And Gen AI will know what data sets to search through, what query to write, and what data to come back. And this is really, it sounds simple enough, and one hand it's simple, but it's just starting, and this is going to change every single industry. Databricks, I put that M, we're known as the leader in enterprise AI. So there's general AI where consumers, like your kids can write their college essays with it. They shouldn't do that. And then there is business AI, business Gen AI. If you want to use your own data and you want it protected so it's not leaked, you cannot leak the healthcare of your players. You have to secure it. That's where you need an enterprise Gen AI solution that's governed everything in-house. So I don't have my timer here. How much time do we have about left? Okay, so this, fortunately, is my last slide. Purely educational. If you follow me on LinkedIn, I have a whole blog on it. But this is where Gen AI is right now. 4 stages. There's prompt engineering, where just ask a question. Retrieval augmented generation, which is where about 90% of the world is. You can give it a couple documents saying, give me insights on these players from scouting reports. The next stage, which is possible today, but few people are doing it, is fine tuning. If you want to make your own LLM in the own language, like in English, the word deceptive is negative, but in baseball, if you're a deceptive pitcher, the batter doesn't know what's coming, that's a good thing. So you want to make an LLM based on your company's data, your industry's data, that understands the complexities and the terminology. That's fine-tuning. And then something that hasn't been possible until a few months ago is making your own LLM from scratch. It used to cost tens of millions of dollars to make your own OpenAI, and now that's reduced to, we did one at Databricks with just $30, but realistically, in the order of magnitude of like maybe $10,000, what used to be millions of dollars. So companies will be able to, they are now, make their own LLMs. And what's fantastic about that is you can take all of this data that you'll be collecting or as a vendor submitting to the teams and have incredible insights. So I'll kind of wrap it up there. I think I'll do one anecdote since there is American football. But when I was with the Montreal Expos baseball team, it's a trivia question. We drafted a catcher, a left-handed catcher, who turned us down, unfortunately, to go play football in America. He ended up being like the greatest quarterback of all time, Tom Brady. But that was fun. We recognized him as an incredible athlete. We tried to get him as a baseball player. Who knows what the future would have held, but data and looking at him as a person combined, we thought Tom Brady was great. But with that, I wanted to thank you for your time, and nice to have this opportunity.